Hi, my name is Pavel. Thank you for joining me for this second session on Windows Phone 8 Development Fundamentals. So in this session I want to discuss the following topics. First we'll start with the resources, talking about logical resources, not binary resources, which are more common and perhaps more familiar. Then we'll look at dependency properties and attached properties and try to understand what these are and what features they have that are important for Windows Phone 8 development. Then we'll discuss data binding, which is in part works thanks to dependency properties, and we'll see how to use data binding in several scenarios to create a nice application. Data binding is one of the most powerful features Windows Phone 8 has. Then we'll discuss data templates and do that actually intertwined with data binding and see what data templates are and how they can be used to visualize data in at least easier way. And finally, if we have time, we'll discuss the application lifecycle and try to gain a bit of understanding of how the phone manages applications running in the foreground, perhaps in the background. We'll see how to deal with state management within that lifecycle. So let's begin with the resources. So resources are really any kind of .NET objects. They can be any object. They are typically stored in a resources collection, which is actually a dictionary. In particular, it's a resource dictionary type that has whatever object we want with some key. And then these objects can be accessed in any other object that is part of that visual tree, and this is used mostly for sharing. We can share various objects such as brushes, geometries, and other objects, and this will be very useful in several ways. I'm going to show you that in a moment. There is another place we can store resources, which is in the application level, in the app.xaml file. So the resources collection is part of the framework element class. That means that every element can have its own resources. But if we want to use some application level resources, that means resources that are available in every page in the application, we really should place them in app.xaml. That's actually why there is a XAML file for the application, because it doesn't have any visual appearance, but resources or application-wide resources are stored there. And to gain access to those resources, we use the static resource markup extension in XAML. We can also use some code to get to those resources, but really static resource is the preferred and the easiest way, because it automatically searches up the visual tree, tries to locate that resource with that particular key, and if it doesn't find that, it goes to app.xaml to see if there is such a resource with that key in app.xaml. If there is, then it uses that, otherwise we'll get an exception. So let's see how that works. Let me go to Visual Studio, and I have here some small application, and really nothing special right here at this time. What I want to do right now is create a canvas here. Let's create a canvas, and I'm going to place two elements here. One of them is going to be an ellipse, and I want that ellipse to have some width, let's say 100, and a height, let's say 100 either. And I want the ellipse to be filled with some nice brush. So I'm going to use the fill property. I'm going to create a linear gradient brush. And I'm going to use full gradient stops here. So let me create something. Let's say at offset 0 I want to place the color, let's say red. And I'm going to copy that in two more lines and create two more gradients. Let's say two more offsets, 0.6, and let's place yellow here, and let's put in offset 1, let's say purple, for example. And what I can see here right now is that my ellipse has some nice, or at least supposed to be nice brush. Let's correct that yellow here, but that's a bit better. And suppose I want to have a rectangle that uses the same brush in some way. So let me create a rectangle here, and sorry, it should be after the ellipse. So here's the rectangle. Now I'm going to move it a bit so we can see that better. I'm going to discuss this syntax in a moment when we talk about attached properties. But for now, I'm just going to move the rectangle a bit. Let's give it some width and some height. Let's make it a square actually. And this time I want to use the stroke property so that the boundaries of the rectangle are drawn with that same brush. I'm going to copy that brush over here, and I'm going to have a stroke thickness, so I'll be able to see something, of 20. And we can see we have the exact same brush used in two different shapes. However, there are actually two instances of brushes here. So they're much the same, they look the same, but they are actually two different instances. If I decide later that I want to change that brush in both the ellipse and the rectangle, we have to make two changes. And that probably is not what I want. What I want instead is to have that brush as a resource. I'm going to cut that out from the ellipse, for example, and go to the resources area in some top level elements. So I'm going to select the page itself, which is the best thing to select, except if I want to place things in the application wide resources. So let me do this for now. And now I'm gonna have to get my my brush here again. Let me cut that out and place it right here. So the XAML compiler doesn't seem really happy. IntelliSense shows me those squigglies, and that's because I'm now part of a dictionary, so I have to have some key. So I'm going to create a key here called brush1, and now everything is fine right here. So how would I use that brush in the ellipse and the rectangle? So I'm going to delete both of these and simply use the static resource markup extensions. We're going to say fill equals and static resource and brush1. We can see the brush used on the ellipse. Similarly, I can do the same thing with the rectangle. This time I'm going to use the stroke property, but this doesn't really matter as long as it's typed as a brush. So here's a static resource called brush1, and we can see the same brush used. Now this is not only economical, it is also economical not in only in the copy-paste sense, but also in the object instance sense. That means that there's actually only one brush. It's simply referenced by two different objects. So if I decide later that I don't want actually to have a purple here, I want to have something different, such as green, I can change it in one place and it's automatically changed in every occurrence of that brush from that point on. So my next logical choice may be that if I want that brush to be used in other pages in my application, I would have to copy that into the resources property in those other pages. So a better approach would be to cut that out from here and place it in app.xaml. App.xaml holds application-wide resources. So if I paste it right here and I can navigate back, I can see that I'm getting the same result. But if I add another page to my app, I can still use the same brush because it's always going to be located when it's in app.xaml as long as I don't miss out the correct key. So that's our real resources. And that's a very useful thing to have, not just for brushes, but for some other types of objects. And we'll see a few examples later on. So the next thing I want to talk about are dependency properties. So what are dependency properties? Usually we think of properties in a .NET sense as a simple wrapper around private fields. But really that's just an implementation detail that may or may not exist. Properties are methods, and we don't really have to use that kind of code. So these simple wrappers are good enough for many scenarios, but sometimes they're simply not enough. One thing that's missing is change notifications. That means that if a property changes, nobody knows about that. So nobody can do anything about that, such as data bind to some other property to change when that source property changes. So dependency properties is a kind of infrastructure that provides extra abilities for properties. That means they're not wrappers around fields, not at all. In fact, they're implemented in a much more complex way, which we'll see a bit later on. So one thing that we get with dependency properties is about change notifications. That means that data binding can work, because when that kind of property changes, it advertises that change, and some other entity can use that change to make some decision or take some action. And this is exactly what the data binding system does. Animations also are dependent on these properties, which is not so obvious at this time, but perhaps we'll talk about that in some other session. And another thing that some properties have is the idea of visual inheritance. That means if I place some property, mostly the font-related properties, on some top-level element, all its child elements will have that same value for that property, unless those elements override with their own local value. So there is some sense of visual inheritance, which is something that works with some properties, mostly the font-related properties. Another important property called data context, which we'll discuss later when we talk about data binding. Another thing that dependency properties allow or provide is a way to prioritize the provider for the value of the property. And that's exactly why they're called dependency properties. That means they depend on some entity giving them the final value. So a simple example would be that inheritance. So an inherited value is not as strong as a local value. So the inherited value is the one that has the effect unless an element overrides that with local value. Another example is animation. Animation changes a property from one value to another value for some interval of time. So while the animation is in effect, any other setting for the property should not be actually have any effect. And that's actually what happens, because animations are the highest priority providers for dependency property values. Another thing that may be of interest is the idea of memory conservation. That means that if we use properties in the simplest sense as wrappers for fields, that means if I have 200 properties, I have 200 fields. And controls have many properties. So if every property is just a wrapper around the field, then every instance will take up a lot of memory. And that's really wasteful, because we typically only change very few properties. So dependency properties work differently. They provide some default value for a particular property, and as long as the element doesn't change that property, there's no extra memory allocated. And that's something that may be important. So how do we know a property isn't a dependency property? Well, we can't really know. The properties we used up to now in XAML, for example, we use this fill property and with property. Actually, they're all dependency properties, and we can't really tell that using the XAML, because XAML can work with dependency properties and regular properties in much the same way. There's really no way to tell. It's only a matter of implementation. However, there are other kinds of dependency properties known as attached properties. Attached properties provide something very different. They're actually built on the same engine, on the same infrastructure, but they are different in the way they're declared and used. So attached properties are declared by one type but used by many, which is kind of strange, because we're not used to that kind of thing in .NET. Usually a type declares a property, and that type can use that property, and every type that derives from that, but nothing more. However, here we can see that one type declares a property, but anyone can use that. That means it can be used to extend an object with custom properties. and in a sense provide properties with a context. That means that they may have some value or meaning in some context but have no meaning in some other context. And again, that can be a bit weird, but actually the simplest example is this canvas dot left that I've used here. So canvas dot left is actually an attached property. It is declared by canvas, but actually can be used by anything. In this case, I'm using that property to set a value on a rectangle. So why is that working like that? Why isn't rectangle have a property called left? Well, the reason is that a rectangle can be inside a canvas, and a canvas is a kind of container that allows me to place elements in particular positions, in exact positions. However, if the rectangle were in another container, such as a grid, the left property would have no meaning. That's why rectangle has no left property. Instead, I can attach a property canvas.left to that element whenever that makes sense. So the canvas is the entity in this case that's interested in canvas.left and canvas.top. So for example, if I go to this ellipse here, I can say canvas.top equals 50, and that makes the ellipse move down a bit. And again, that only works because canvas is the one that containing that ellipse. Does that mean that attached properties must be used by elements that are contained within the declaring type? Not at all. This is just we can say for now that's just a coincidence. Let me change the canvas to a grid, for example. Here's a grid, and I'm changing that container to a different container. We can see the output is different, and in this case the canvas.left and top have no effect. Let me change that to 150, and nothing happens. That's because the grid doesn't care about canvas.top, so it doesn't look for those properties. However, that's not an error as well. It means that I can have those properties that simply have no meaning at the way I've used them right now. So these are attached properties, kind of weird at first, but very, very useful. Let me give you a concrete example of how to declare that kind of property and how to use that. So let's say I want to rotate my rectangle. So one way to do that, use some properties. I want to use a property called render transform. Here's render transform, and I can provide a rotate transform object here with an angle of 45 degrees, for example. And what I see is that the rectangle is actually rotated 45 degrees. And it wasn't rotating around its center, it's actually rotating around its top left corner. If I wanted to rotate around the center, I'm going to change another property called render transform origin. I'm going to place a point here known as 0.5, 0.5, meaning that the transformation is going to be around the center of the object. So naturally, I can make these rotations on any element that I want, but this is really too verbose. I want to have something simpler. For example, I want to write something like this. I want to say to the rectangle, rotation or something similar, 45 degrees. This is what I want to write. However, currently that of course won't work because rectangle has no property called rotation. However, I can create an attached property that I can attach to a rectangle or to anything else and make that rotation. Let's see how to do that. So I'm going to go to my project and add a new class. Let's call that display attributes or properties. It can be any class. I'm actually going to make it a static class because it's going to have only static members. And what I want to do here is to declare that rotation attached property. To do that quickly, I can use a code snippet called prop A. Prop A means property attached. I'm going to click tab twice, and then I can select the type of the property. So it's going to be a double because I want it to have the angle of the rotation. my property name is going to be rotation, and the owner class is display properties. And I'm going to have a default value of 0.0. That means I will not have any rotation by default. And we need to have another using statement here, system.windows. Let me just add that. And here we actually have the attached property. So attached property is called rotation, and what we can see is that there is a static read-only field that actually manages that property. Here it's called rotation. It's of type double. This is the owner that actually declared the property, and here we have some metadata for the property, and the only thing we have here right now is a default value. And these get rotation and set rotation methods are actually the way that a property can be changed with code, and actually very similar to what the XAML parser does when I'm using that property in XAML. So let's try to use that. Let me go back to my page, and now I can try to use rotation. Naturally, I can't use rotation because that's not the correct syntax. The correct syntax should be the name of the class dot the name of the property. So let me write here display properties dot rotation. That's also not good enough, and that's because this display properties class is unrecognized in the default XML namespace. I have to actually create another XML namespace. So the way to do that is declare an XML namespace with some name. Let's call that local. That's just a name. And then I can use the IntelliSense to help me out to use the ResDemo namespace in the ResDemo assembly. And that actually gives me a way to access any types in that namespace. I can see that my display properties class in the ResDemo namespace, I can access that from XAML. So now the correct prefix would be local colon display properties dot rotation, and that should be good and should compile without a problem. Let me build that. That actually builds okay. Let me run that. So let's see if we have something here. Oh, sorry. We need to rebuild the solution. Let's rebuild that. Okay, and try to run it again. So here's my my emulator. Let me just make it a little smaller. So here's the emulator, and you can see that the rectangle is nowhere rotated. And that's actually pretty understandable because we haven't done anything to make that happen. We simply defined a property. What we need to do now is act on changes to that property. Now, since an attached property is really a dependency property, it has the capability of notifying when it's actually changing on some object. So I'm going to add another parameter here to the property metadata constructor, which can be a delegate that is invoked when that property changes. Let's say on rotation changed. Let me generate that method with the help of Visual Studio. And then what we get here is a callback when the property is changing. So what I want to do here is do something when that property changes on that object D. So first let me make sure that object is actually an element, because the attached property can be used on any object. Technically that has to derive from a dependency object class, but it can be anything, not just elements. So I want to make sure that I'm working on an element, because if it's not an element I cannot rotate that. So let's test if that element is not null. If it's not null, I can do what I did in XAML in the first example of the rotation. So I'm going to first use the render transform origin and set it to a point which is 0.5, meaning I want to make transformation from the center of the object. And then I want to create my transform. So I'm going to create a rotate transform. Here's my rotate transform. Let me bring in the namespace here, and I'm going to give it an angle of course, what the the value of the property is, and that value is actually provided using the args here. There's a new value property here. So I'm going to say e.newValue. This is the value provided on that element. And then I'm going to set the render transform to that rotate transform object. And that should be enough. If I run my application now, I should see the rectangle rotated. And that's really all I need to do to make that rotation work on any element. So if I go back to my page here and I add some other elements, such as let's add a button, for instance, and make it with some content. So now if I look at the button right now, it just appears as a large button. Let me make a margin here so we can see the boundaries better. So here's the large button right here. Let me rotate that. So all I need to do is use local display properties dot rotation and whatever angle I want, such as 120 degrees. So here's my button. It's rotated and still works like a regular button, in the sense that I can use it to click. Here's the button. I'm clicking on it right now, and if I had a click handler, that would be invoked. That's the power of attached properties. We can actually extend objects with new functionality without any need to derive a new class from button or from rectangle or anything like that. That's one interesting use for attached properties. So that's attached properties, and we've seen the canvas.left and canvas.top attached properties that are defined by canvas and allow elements to be placed in particular coordinates. Similarly, when working with a grid, we can use the row and column properties that grid defines to place elements in particular row or column, because grid is really a row kind of similar to an HTML table. So this is an attached property which only has meaning if that element is inside the grid. If not, then there's really no meaning to using these properties, but they don't cause any harm because they simply are not interesting to anyone. So that was the attached properties. I'm going to show you an example of dependency property, a regular dependency property, later when we see an example of data binding. So let's talk about data binding. Data binding is really a huge subject, and we can't really cover everything in this short session, but I will show you some common examples of using data binding to give you a sense of the power of data binding. And this is really something you should look at always when writing applications. So data binding really means tying two objects together. That means that when one property on some object changes, some other property on some target object changes in some way related to the change in the first object. That's really pretty simple. These objects can be anything. They both could be visual objects, but can also be non-visual objects. The typical scenario is a non-visual object. That means some data object that is bound to some or connected in some way to a visual element. So when anything changes in the data, the visual element that shows something about that data changes automatically without me having to write any code, simply by creating the correct data binding connections. So the binding can be one way. That means when the source changes, the target changes consequently, but it could also be in the opposite direction. That's called a two-way binding. So that means when the target changes, the source can be updated as well. A typical example would be a string, for example, that's tied to a text box. So if the string changes, the text box would reflect the change. But if the user types a new string inside the text box, that text can change the original string. So there's a two-way binding there. Now bindings in Windows Phone are one-way by default, so if we want to make them two-way, we have to actually specify that in the binding expression. And actually data binding is the basis for the powerful and very useful model view model pattern, which I'll show you briefly in the following demo as well. So what I want to do now is just go through some examples. So the first thing I want to do is get rid of that grid and all these elements. Let me get rid of that. And I want to use a stack panel here. And I want to show you a simple data binding scenario, which is not super useful, but give you an idea of what data binding is. So I'm going to use a slider here. Let me give it a name. Let's call that slider 1. And give it some minimum value, let's say 10, and a maximum value, let's say 100. And I want to place a text block here. And let me place some text here, such as hello binding. And what I want to do is, let me give it a name. Let's call it text 1. What I want to do is that when I move the slider, I want the font size of the text block to change accordingly. So how will I do that? So the obvious way is to use events. So I can say when the value of the slider changes, there's the value changed event handler. I can connect that to a handler such as on value change, and then I can right click and navigate to the event handler. I can say, okay, so if my text block is already initialized, I can take the font size and use the slider's value property to place that inside the font size. So because they are both the same type, a value is a double and font size is double, I can simply make that change. When I run the application, let me run that. Here's my email emulator. I can move the slider here. I can see the font size changing as I expect it to change. So that seems perhaps easy enough. So there was a little bug here when we started the application. The font size wasn't actually aligned with the current value of the slider, but that's something we can fix, which we won't do right now. So what's wrong with this approach? So the problem is that this is something that I have to program as a developer, which I don't want actually to do. I want the visual designer or the one doing the user interface or user experience to make those changes without me actually having to write any particular code. And so I don't really like that. I want to use as a developer, I want to work on the actual logic of the application, not about some visual changes that have actually no effect on the actual logic. So I want to use data binding here. This is a very simple case, of course, but still sometimes useful. So what I want to do here is change the font size of the text block based on the value of the slider without writing any code, but by simply using data binding. So here's the way to do that. So I'm writing the font size target, that's the target property. I want that to be bound, so I'm using the binding property, the binding markup extension, and then I should place the actual property I want to bind to. That's the value property. And the next question is, what is the source? What's the object for which the value property should be extracted from? And that's actually the slider. So in this case, the slider is an element, so we use the element name property. And here's my slider 1 name right here. So that's all that I need. I have a target property, which is font size. The target object is the text block, and the source object is the slider, and the source property is value. Let me run that. So here's my slider, and again I'm moving that, and it's working as expected. And I didn't write any code for that, and even when the application first started, the values were aligned perfectly. So that's a simple example of data binding which involves element-to-element binding, which is not the most useful binding, but still may be useful at times. So let's try to do some other kind of binding. So let's create a data object. Let me right click here and create a class. Let's call that class a person. We'll just add some simple properties to person. So let's say I have an age property here and a name property here. And now I'm going to get rid of that slider and the text block, and I want to create that person for now as a resource. Let me write here local, that's the prefix I defined previously, and person, I'm going to give it a key, otherwise that simply won't compile. Let's call that P1, and I can set the properties name and age with some values. Let's say Bart and 10. Now I can place a text block here, and I want to make, let's give it a large font size. I want to make the text have the name of the person that's in the resources. So I can say binding, my property should be name. That's the property I want to extract from the source. But what is the source? The source in this case is not an element but an object. So I need to use another property, not element name. The property is called source. And the source is actually something coming from the resources. So I'm going to use static resource P1 to refer to that person. And if I close that tag, and at this point my designer has not yet caught up with me, so let me run that to see what's going on here, and I can see the name Bart right here. So the property name was extracted from the person whose key is P1, and I can also see that in designer right now. Let me copy and paste another text block, and this time I'll go and try to extract the age property. You can already see in the designer that the value is actually 10, and if I run that, the value is still 10. So that's something that's working as well. That may be a bit surprising because the age property is actually integer and text is a string. So you can see there's kind of some type conversion that's going on behind the scenes that make this work without any effort on our part. Now that's another simple way to work, but in this case our data is created in the resources, which is really not very useful. Most of the time the data is going to be created programmatically, perhaps by reading information from a database or some web service or something like that. So naturally we probably want to use some other way to get to the source. I want to get to the source without actually specifying any resource. So let me do something like this. I'm going to erase the source. Let me get rid of that. I'm going to get rid of the source right here as well. So what I have here is just binding to some property, but there is no source object. That means that right off the bat that the binding actually fails. I can see nothing in the designer, and when I run the application I can see nothing as well. However, notice I'm not getting any exception. That's because data binding failures don't generate exceptions, and that's actually by design, and we'll see some logic why is that so a bit later on. So one thing that perhaps is becoming obvious, that this binding may not be working right now, but perhaps I can do something later that will make this work okay. And actually there is something I can do, and that something is using a property called data context. So data context is a property that has a visual inheritance. That means it goes down or turns down the visual tree, and actually provides us a default source if one is not specified in some binding expression. So if I create a person here, let me create a reference to a person here. Let's call that person, and in a construct I'm going to create that instance of person. Let me place some name here, Let me use another name, another age, just to make sure I'm not using that something in the resources. And now I'm going to place that person to become the data context of the page. That's this .data context actually, so I can write that, I don't have to write that. And this data context becomes the default source. What that means that when I'm running my application, I can see the new values appear as needed. So I can see that even though I haven't specified any source, there is a default source which is the closest data context up the visual tree that is not null. And this is a very interesting way of working. Is actually the basis of one of the basic principles of using MVVM, the model view model pattern, which I'll show you in a moment. So what else can we say about that? Let me do something else. Let me add a button here, and let me get an event handler to that button. And what I want to do with when that button is clicked, I want to increment the age of that person. So I want to say person.age ++. And what I expect to happen, I expect that age to increment right here. So I'm clicking add, nothing happens. Clicking add as many times as I want, but the age doesn't seem to increase, which is strange because I'm using data binding here, so I expect the data to actually update when the source changes. I expect the visual elements to update. That doesn't happen. Let's try to place a breakpoint here. Perhaps we have some bug and we don't get to that breakpoint, so I'm going to run with the debugger. Let me click the add button. We're actually getting to that method. And age is right now 12. When I'm stepping over that, age is 13. So that actually works. It seems to work. So why am I not seeing any changes? And again, age is 13, so I'm stepping over again. Now it's 14, and again, no changes. So perhaps you're guessing why that is. And the reason for that is that person here has simple properties which are actually wrapping private fields. So when that property, such as age or name, changes, nobody actually knows that they changed. So data binding system is not magical. It can't really tell that that property has changed. We have to change something in the implementation. So how can we do that? One way is to change that property into dependency property, which will automatically have change notifications which Windows Phone can pick up and make the changes. But that's really something we don't want to do for data objects. One thing that is not very nice here, that we have to inherit from a class called dependency object, which is something that we don't really want to do. We want to keep our data objects clean. Perhaps we're using them in some other context, in another type of application, so we can't really do that. And even if you could do that, inheriting for something is very expensive because we can't inherit for anything else. So we don't want to do that. The other way to work through that is using an interface called iNotify_property_changed. This is a well-known interface in .NET. We need to add the using system component model namespace. And we can actually implement that. And actually only has one simple event called property changed. And that event has to be raised when anything changes in any property. So the way to do that is by making the property work with some actual field. So in this case, I'm going to make my age, as it's going to be able to change, a regular, I'm going to declare the field myself and then raise the event as needed. So I have to say return age here, and when I'm getting a setter here, I have to perhaps do some checking, such as make sure that the current value is really different, the new value is different than the old one. In this case, I want to raise the event. So to do that, to make the change and raise the event, so making the change is easy. I'm simply going to say age equals value, but how do I raise the event? And one common way to do that is create a method to do that for me. So I can say protected virtual void on property changed, like this, and have some property name. And then I'm going to look at the property, the event itself, to see if any entity is actually registered, and if they have, I want to raise that property in the usual .NET way. So there's a property change event args here that actually must have the property name. So here I'm simply going to call on property changed with the string name. And once I do that, assuming I haven't made any error, and run the application again, click the add button, nothing happens again because that's not name, that's age. So I have to be really careful here. And now we can see the data actually changes and the visual appearance of the age changes as well. So we got to have some notifications. This is the common way to do that. And naturally we will have to do the same thing with the name property. If that property is ever to change, then we would like that to be reflected in data binding scenarios. That's something to keep in mind, and I'm going to show you a more general solution to this problem in a moment. So that's simple data binding. Now what I want to do now is look at a more complex example, more real life, using some application. Now first I want to run the complete application to show you what I want to get at. So I want to have some movie browser application here. I can look at some movies here that have come from some database or web service or something. Each movie has some image, text, and a possible rating. And we can have some elements here such as all the movies, and we can only look at new movies that have been out in the last 4 months or something. And we can look at upcoming movies that haven't been out yet, haven't been released yet. So we can see here there's a new control here that we haven't seen specifically. This is the pivot. I'm going to show you how to work with the pivot in a moment. That's the application I want to get at. So let's see how I can do that. So my application is called Movie Browser. I've already created some minimal UI here. I can see the main page that actually has nothing interesting. So I want to start creating something interesting right here. So the first thing I want to do is create that pivot. So that pivot is part of the phone namespace, XML namespace here. We can see that right here. It's in a namespace called Microsoft Phone Controls, in assembly called Microsoft Phone DLL. So it's already referenced by default by Visual Studio. All I need to do is just use that. And that's because the pivot control is defined in that namespace and not in the default namespaces that the default XML namespace points to. And I can have some title here. Let me write Movie Browser without spelling mistakes. Now every pivot has pivot items. So in the example we want to have 3 pivot items. So again, pivot item class is also in that namespace. So I'm going to use pivot item and have some header. So I want to have one that says all. That's going to be one item. I'm going to copy paste that and have 2 more items. I want to have a new here and upcoming. So now I can actually run this and get that nice user interface. I can simply move along using sliding with a touch, or simply by clicking or touching these titles. So we have our pivot, but our pivot items are empty. There's no content here, and that actually really makes things really boring. So we want to have something inside that. So what I have here is a class called movie, and this movie represents a movie. It may have some ID, a name, a release date, a rating, and some URI with an image that actually comes from the web. And suppose I can get a database of those movies by using some web service, for example, or some other data source. And in this case, I simply have a local database right here, but in a more real-life application, I would probably get that information from some movie database service, such as IMDb or something like this. So what I want to do is be able to present those movies in some way. So the way to do that is usually to use data binding as much as possible, and that's usually done with the MVVM pattern. An MVVM pattern means there's a model, which is the data. In this case, our movie is a model. There's a view, which is the actual user interface, and there's the view model in between. The view model is a kind of mediator that exposes the model in an appropriate way for the view to consume, because the view wants to have properties in a particular way, and perhaps some of the model uses methods, for instance, which is something that data binding can't work with very easily. So perhaps the view model is going to make these methods into properties. So the view model is kind of something that provides an adapter for a model to be useful for a view. So every view usually has one view model, which looks at one or more models to abstract to the view. So that's a really simplified expression of MVVM. That's actually, there's some more complications there, but I'm not going to discuss everything here because that's a really a big topic. So I want to simply use some practical approach to make this work. So the first thing I want to do is create a user control. That user control should give us the ability to show some collection of movies. So let's try to do that. So I can right click and say add a new item, and look at Windows Phone here. There's a user control here. So let me create a control called movie list control. Remove that one here. So a user control is something that should be familiar from other UI technologies. It's simply a container for some, in this case, XAML markup. And what I want to do here is use data binding to show a collection of movies. So I'm going to use a list box here. And a list box actually binds using a property called items source, which should be a collection. In this case, I want to have a property called movies that is bound on the actual element. So that looks kind of perhaps strange, but I want to give the element a name, our user control. I can give it a name that will give me easy access to its properties. And I want that user control to have a property called movies. That's fine and good, but currently it doesn't have any such property. So we need to define one. So I'm going to go to the code behind file, and it currently has really very few lines of code. I'm going to add a dependency property so I can have data binding work seamlessly because of change notifications. So how do I add a dependency property? It's actually very similar to adding an attach property, but this time with another code snippet called propdp. I'm going to tab twice, and what I want to have here is a enumerable of movie. That means some kind of collection of movies, and that property is going to be called movies, and the owner class is the movie list control, and the default value would be null. So I'm going to just add a reference using statement for the movie class, because that's defined in another namespace. And now I have that property. That means that property can be set from somewhere outside this control. Let me move back to the markup. So the list box should present the movies. So perhaps I don't need anything else. Let me let me stop right here and move on to using that control. We'll see that we'll have to add some stuff here, but for now let's try to use the control. So I'm going back to my main page. So actually I need 3 instances of the control. One for the old movies, one for the new movies, one for the upcoming movies. Each one will simply display a different set of movies, but actually the same control. So first I want to declare that control to be available for me. So I'm going to use the local prefix I've defined previously. So I'm going to use, just this time it's a different project, of course. So this is the movie browser application. So I'm going to be movie browser namespace, and this is where I placed my control. That's movie browser namespace in my own assembly. So now I can write local like this, and I can see I have my movie list control in the IntelliSense, and here's one. Let me copy that. Here's another one, and here's another one. So now I have that control, but naturally it probably will not show anything because the movie's properties haven't been set to anything. I need to put something in here. So how would I put something in here? I'm going to use another binding expression. I'm going to say, okay, let me bind to a property called all movies. So that's all good and well, but naturally I have a problem here. I have a property, but what's the source? Can I write source something here? I really can't. Instead, I want to rely on the data context. And data context is all that matters. So the data context is going to be my source, which this is going to be my actual property. And I'm going to write the same or something very similar to the other movie list control elements. So I'm going to write here new movies. And here I'm going to write upcoming movies. So I'm actually using some properties which I haven't created yet. I need to create them somewhere. So the way to do that, I'm going to create another folder. Let's call that view model. View models. I'm going to create one view model here. I'm going to name that main view model. And what I want to do here is simply have those properties available. So let me, for example, try to look at something like, I want to return an IEnumerable here of movie. And again, let me getting the namespace. That's called all movies. That's the name of the property. I need to get it right. So what I want to do here, I'm going to simply use my movie database, and we have movies here. So I'm going to simply return that as the object. If I want to do something very similar for the other 2 properties I want to support. So again, I'm going to return a movie collection that's called new movies. So what's new movies? Anything I want that to be. Let me just paste in some code to make things a little shorter, at least quicker. So I'm going to look at my movies, and I'm going to add the link expression here that says if the release date is older or than now, that means that it's already been released, but let's say 100 days have not yet passed, then I want that to be returned. Otherwise, I don't care about that. And we should do something very similar to return all the movies that haven't been released yet at all. So let's call that upcoming movies. That's exactly the same, the name of the property that I'm supposed to bind against. And here I can say movie database dot movies, where if I have some movie, I want that release date of that movie to be greater than the current date and time. So that means that movie hasn't been released yet. I'm going to make that an array to force the execution of the query right now. And that's my properties right there. That seems nice, but how do I use that main view model? So the typical way to do that is to actually create that view model right here in the application class. even as a static object, because the application class is a singleton anyway, and want that view model to be available from anywhere. So let me create that view model property here. Again, let me bring in the correct namespace. And the property currently has the value of null. Let me create one right here. So view model equals a new main view model. Let me make that a property that is only settable by the application class, but can be used by anyone. And now all I have to do is make sure that when my page loads up, the data context is the view model. That would make my data context the default source. That means that the page will actually bind here to the all movies property of that main view model. At least that's what I'm hoping will happen. Let's try to Visual Studio as seem to having some difficulties. Let's hope it. Okay, so the designer, Visual Studio Designer crashed. Never mind. Let me build that. So there's a return statement missing here. So let me fix that. Let me build that again. And if you run that, let's try this. What we see is that we get something. Maybe not quite what we expected, but we're definitely getting something. So we're getting all the movies here, and there simply looks like the toString of a movie. And when looking at the new movies, we can see there are only 2 movies here. And the upcoming movies, we see there are only 2 upcoming movies. So that's nice, but definitely not what we want. We want to have a different visualization of a movie. So why did we get what we got? Well, that's simply because our user control has a list box and nothing else. So it's binding to the movies property, but it doesn't have anything else to say about those items. So naturally, all that's possible is simply calling toString on these objects. We can actually do something a little better. I can say something like display member path. That gives me a way to select a particular property to look at on a particular movie. So if we look at the movie class again, there's a property called name. We can try to use that. That's probably the simplest thing to do. Let me write name here. Then we run the application now. We should see something that's better. That's much better. We can see that these are all the movies in my database. Here are the new movies that have been out in no more than 100 days, and these are the upcoming movies that are not out yet. That's better. We can see some actual data here, but certainly nothing like the application I showed you previously. We want to see the image, we want to see some other more interesting stuff. So how do we do that? So display member path is an easy way to go, but it's really very limited because it can only select a single property and renders that as text. The way to do that for all types that inherit from items control, that means they provide a way to look at more than one object, such as list box, is used a data template. So there's a property called item template that is of type data template. That data template says how do we want to look at a movie? How do we want to visualize a movie object? That actually could be anything we want, but with the correct binding expressions, we can have something that's more easy on the eyes. We can look at that and actually have some fun here. So let's see how we do that. Let me create a grid here with some margin. And I can only have one object, so it's usually going to be some layout panel. Then I can do whatever I want in there. So I'm going to create a few rows for that grid. I want to create actually 2 rows. So the first row is going to have whatever size I need, and the second row is going to have the exact size that's needed by elements in that row. I'm going to show you in a moment how that works. So the first thing I want to do is use an image to show the bitmap of that particular movie. So I'm going to give it some width and some stretch properties, so it just looks the way I want that to look. So that should be right here after the raw definitions. Let me stretch the image as uniform so it looks good, and let me make that centered if needed. And now I want to provide a source for the image. So the source is going to be a bitmap image, which is a class that is an image source derivative that provides a way to read an image from, for example, a URL. And I'm going to use the URL source property to show that image. The way to do that is to bind to a particular property of the movie class. In this case, that's image URI. And again, if I go back to the movie class just to make sure, my property here is named image URI. That's the URI that I want to bind to. So actually the item template looks at a particular item, which is a movie object. And I have to provide the correct properties in the binding expressions. Notice I don't have a source here. I don't need any source because the automatic source is the current object. That means the current movie I'm actually trying to render here. We can already test that. Let me run the application right now and see what we get. So we can see the actual bitmaps right here. Here are the bitmaps. I'm actually scrolling them. It doesn't look right the same as it did in my first demonstration, but we'll make that happen soon enough. So if I look at the new category, I can see there are different movies here, only 2. In the upcoming movies, here are the movies right here. So we're getting there, we're getting closer. We've used the image URI property. Now I want to use the name property. Let me also make the background black, so it have some better effect, I think. So after I have the image, I want to now have some text. That's a text block that writes the name of the movie on top of the image. So my text should be bound to the name property of the movie. That's for sure. The only thing I have to do now is simply provide some alignments and some other properties that I want to use. Let's say I want to have vertical alignment of center, horizontal alignment of center, so it's be centered over that image. Let me have some font size, let's say 20, and let me have some margin, and perhaps I don't need that margin right now. I can use some text wrapping in case the name is too long. So I'm going to use the wrap property here. So let's try that. So that's not too bad. Some properties, some of these items are a bit long, and this looks a bit off because when the text is long and the image is centered, it's not really the way I wanted that to look, but it is a start. So what I want to do is make these items more in a kind of grid-like fashion. So how would I do that? So by default, a list box really works with a stack panel. That means that every element is below the previous element. I want to do something different, use some other panel, and there's actually no such panel by default in Windows Phone. It's called the wrap panel. However, it does exist as part of the Windows Phone toolkit, so I can use the toolkit. So to get the toolkit, we can go to the Codeplex website, download the toolkit, and then use that, but there's actually a better way. We can use the NuGet, a NuGet package to get that. So I can right-click the project and say, select Manage NuGet Packages. And we simply search here for the phone toolkit. Okay, let's try again. Nothing. Let's try toolkit without phone. Alright, so something is... here's Windows Phone Toolkit. We got that. Let me install that. So the installation downloads the toolkit and adds the correct assemblies to my project. And that's really great because if the toolkit is ever updated, my project will get updated automatically as well. So you can see the toolkit reference right here, Windows Phone Controls Toolkit. And there is another toolkit content here with some images. We can simply use that. So to use the toolkit, we first need to map an XML namespace to the toolkit. So let's use the T prefix. So I want to have some Microsoft phone or something controls from the toolkit. So let me do that. And the namespace is going to be called T. So what I want to do now is use a different items panel for the list box. That's another property we can change. So by default, that's a stack panel, but you can actually use something else. So that's another customization, very powerful customization option for a list box. So let me use items panel template, which is the only template that's provided, and then I can select whatever I want. So I want to use T : and select a wrap panel here. That's the panel that allows me to do the thing that I want to do. So let me select a width so that it's properly aligned, and let's select a height as well. Let's say 260. Another thing I can do to make things a little prettier, to make sure that scrolling is not available horizontally, only vertically. So I'm going to disable horizontal scrolling by using an attached property called scrollviewer.horizontal scroll visibility. And let's try it right now. So I'm going to build that, and that's much better. Okay. So we're getting there. It's actually looking very similar to the thing I've shown you at the start. The only thing that's missing is the rating right here. The rating is missing. And the black background didn't take because the background here is different. So let me just change the background here to transparent so that it actually doesn't make a different background for the grid. And we're almost where we wanted to be. The last thing I want to do is do something with the rating. Now, the rating is interesting because in our model, let's look at the movie again, the rating is an integer. But what we want to show is an image. And actually, I've already created several images here under assets rating called *1, *2, and *3, and so on. And you can see that simply there are images with the correct number of stars. So we need to have some image that is going to be selected using the correct rating. Let's try to do that, and we'll learn something interesting along the way. So I'm going to back to my my user control, my movie list control, and I need to have another image here that in this time placed in the second row of the grid. And that image, let me again align that horizontally and perhaps have some margins so it's not going to be too crowded with the previous image. And let me have some height for that, let's say 24. And now I need the source for the image. Clearly I need a source here. So I'm going to use the source property again. And I'm going to use the bitmap image and URI source here. And that's going to be a bit problematic because I know I want my URI source to be somehow dependent upon the rating. So I'm going to say binding rating. However, that's going to be a bit of a problem because rating is just an integer. URI source is a URI. There's no way these can match. We can see that actually there's nothing happened here. I didn't get anything. And that's pretty obvious because some conversions simply cannot be done automatically. So we've seen previously that an integer can be turned into a double or a string, but this is really too much. Windows Phone doesn't know how to convert an integer into a URI source. That's simply, or URI, it's simply not possible. We can help out by creating something known as a converter. A converter can make the correct conversion between one type and another type so that things work out as we expect. So let's try to add a converter. So I'm going to add a folder here to make things more convenient, called converters. I'm going to add a converter. Converter is simply a class that implements a particular interface. Let's call that rating to a URI converter. And that's actually something that has to implement an interface called iValueConverter. Let me add that interface. It resides in another namespace, if I write that correctly. So it's in the system Windows data namespace. I'm going to add a using namespace, and then let Visual Studio implement that for me. So it has two methods, a convert and a convert back. Convert means when the source needs to be converted to the target. Convert back is relevant for two-way bindings, when the target needs to be converted back to the source. In our case, the convert method is enough because we're only using one-way conversion here from a rating into an image and not vice versa. So how we do that? The first parameter we get is actually the value we're providing to the binding, which is the rating itself. So I'm going to simply cast that into an integer. And now I want to do something like this. If the rating is greater than 0, I want to create a URI that is the correct image, which is assets and rating and star and plus the actual rating. Let me write toString here to be explicit. And I need to add the suffix PNG, because all my files here are PNG files and they're under the assets rating folder. So I have to create the correct name, and then I'm going to use the URI kind relative to make sure that I understood as this URI is not something from the web but something that is local to my project. And if the rating is not greater than 0, that means it is 0. So I want to return nothing in this case, so there's probably no rating for that particular movie. For example, that may be a movie that hasn't been released yet, so there's no rating there. So that's my converter. My converter is simply a class. I now need to create an instance of that class and use that somewhere. So let me get back to my user control. So I need to use that converter in the binding expression. So first I need to create an instance, and that is typically done in the resources. So I'm going to say user control dot resources. Now I need to use the converter's namespace, so I have to add an XML namespace for that. Let's call that conv, and we have a movie browser here dot converters. I'm going to select that. Let me just align that for niceties, and then I'm going to say conv colon, and here's my converter. Let me give it simply a name. Let's call that rating to image. And now I can simply use that instance in the converter right here. So the way to do that is use another property of the binding called converter. And the converter is of course a static resource called rating to image. It's just a name. That's actually the key I gave to that particular object right here, rating to image. And if everything has gone correctly, this should give me a way to view the ratings. And here they are, exactly as I wanted them to be. Here are the ratings for the new movies. And here in the upcoming movies there are no ratings, which is understandable as these movies haven't been released yet. And of course here we can see everything, the upcoming movies and the existing movies. So we have something very powerful here called a converter. A converter turns one type into another, or perhaps even one type to the same type but with a different value, with using some whatever code I want. So in this case I'm saying let me give the rating property as an input to the converter. The output has to be something that the URI source can handle, which is the URI, actually URI type. and here's the converter to do the job. Without the converter, the binding simply silently fails. So with the converter, I can actually do some pretty amazing stuff. And that's just a tip of the iceberg in a sense. So we have an interesting application right now that uses data binding. Notice that I haven't actually touched any data in my code behind. If we look at the user control, there's no code here that does anything to any element. Everything is done using data binding, using the XAML actually. So that's a very efficient way to work. I don't have any code behind here. And of course, that's not everything about MVVM. We haven't talked about commands, for example, which is a way for the view to call back to the view model to execute some actions. And perhaps we'll see an example of that in the next session, but that's something to keep in mind. In this case, the view is consuming properties from the view model, but not the other way around. So the main view model here provides data that anyone can consume. And again, the way that works is that we have to place that instance into the data context property where appropriate. In this case, it was done in the page level. So in the main page, we place data context as app.vmodel. That means there is default source for all data bindings. So that's a kind of comprehensive example of many of the features of data binding. We've seen data templates, which is a way to render objects. So by default, it's rendered as a text block with a toString implementation, which is mostly not useful. So that's a very powerful way to visualize any data. We can visualize any object with its own template. In this case, we visualized a movie object with a data template that's provided, in this case, to the item template property of a list box. But there are actually other properties that accept data templates as input. And the other thing we saw was value converters, which is another very powerful abstraction that we can use to translate from one type to another, or create some very interesting effects by writing some code behind. And that makes our XAML more interesting or useful, because we can combine some very interesting effects pretty easily. So value converters, data templates are great additions to data binding in general. So that was also data templates. So as we come near to the end of this session, I'm going to leave the application lifecycle topic for the next and final session. So thank you for watching.